In Europe, more than 30,000 wastewater treatment plants work around the clock to turn sewage into cleaned water. However, as the weather changes, pollution increases and regulations tighten, this task is becoming increasingly challenging. Could artificial intelligence possibly help human operators overcome these challenges?
I think AI tools could be very useful for us in helping us make the smaller adjustments during the day and night.
Tilburg's wastewater treatment plant is one of the largest in the Netherlands. It purifies 10,000 cubic meters of water every day, releasing cleaned water back into the Zandlei River. But the treatment plant at Tilburg is about much more than sewage.
Here we have a wastewater treatment plant with an energy factory and resource recovery factory. So there's lots of process units and they all need to be coordinated as best as we can. So to have the best effluent quality for the lowest price or the lowest energy consumption and the lowest emission of pollutants like CO2 and laughing gas.
Wastewater treatment plants like the one in Tilburg act like circular economies, trying to reduce waste and maximize the use of resources. Achieving this is becoming increasingly complex.
So the overall challenges we face are climate changes, demographic changes. We see more and more heavy rains coming in, and these dilute our water, so we also have to adjust for that. Then we have sometimes no rain at all. It's getting more and more complex here, and to get all of these things under control is quite hard.
That's why the Tilburg Wastewater Treatment Plant participates in the EU-funded research project DARROW. Data scientists, engineers and water operators are working together to build a suite of AI tools that can help treatment plants run smarter, more efficiently and with less environmental impact.
What DARROW stands for is getting this artificial intelligence and automatization into the world of water treatment.
One of the operators at Tilburg, who will use those AI tools to keep the data and control system running properly, is Bart Rommens.
On a daily basis, for me and the other operators, it's usually checking the SCADA systems, calibrating the sensors and doing normal process controls outside.
A modern wastewater treatment plant like this one is covered in sensors measuring pH, nitrate, ammonium and temperature, to name a few. These sensors generate a continuous stream of data that is difficult to process fully in real time. This is where artificial intelligence could step in.
AI can check the system continuously, all day and all night, and make small changes continuously.
For operators, it's not possible to look at it 24 hours a day, and AI could help with that and could save some energy.
The first AI sensor put into action at Tilburg was the UV-vis spectrometer. This was installed in the influence channel where bacteria feed on nutrients in the wastewater.
We installed a new sensor that we didn't have here at Tilburg. That is a UV-vis sensor. It sheds a light to the water that comes in, and from that we have a breakdown of components that are in the water. And for us the most important one is the COD, and that's the chemical oxygen demand. So it measures how much oxygen do the bacteria need at a certain time.
Bacteria are the main active ingredient in purification tanks at wastewater treatment plants. Different kinds of microorganisms all require specific conditions to digest the waste in the effluent and transform it into cleaned water.
The water cleaning is half done mechanically, so we take out all the greater parts and everything that sinks we take out, and then the rest is done biologically. It's also done by bacteria, but by different bacteria. Some bacteria need oxygen, so we feed in oxygen, but also the digesting bacteria, they cannot survive in oxygen, so they have to have no oxygen. So it depends on which bacteria it is. And basically for us as operators, it's making sure that those bacteria have the best environments where they have the best production. I'm looking at the amount of bacteria inside the tank, so to make sure it's enough and not too much or not too low.
Every bacteria has properties, and all these properties are put in formulas. and made a computational model. And this is very useful because when we have that, we fairly know how the system in its whole will react. And we can predict with that, and we can also, for a certain period, control with that. And we used it in this project to train the AI model, because we don't have a lot of historical data.
The AI models are trained on millions of different scenarios, trying different control strategies, receiving feedback on the results, and learning which settings produce the best outcomes across all possible operating conditions.
What the AI tool does is it trains itself by a mechanistic model, and it learns that by doing it 1,000,000 times, and then it tries to derive the best settings for every situation. That's how it works. If the tool is trained correctly, it oversees much more than an operator can see.
An AI system that watches all sensor streams simultaneously could detect anomalies such as small changes in temperature or dissolved oxygen levels. However, the key to implementing AI in a critical industrial environment lies in ensuring safety.
First of all, we need to build trust, of course. We need to see that the system makes sensible decisions. And then in a later stage, we can integrate the set points that the tool gives into the real plant. Of course, there's also always a thing that the AI doesn't know. So the operators always need to be involved, because there are always exceptions, always something goes wrong or something fails. And yeah, you can't leave that to an AI.
The AI tools are data-driven. It decides changes based on the data it's given. But if the sensors are not calibrated and cleaned and checked, then the AI will take the wrong data and make adjustments to it. And so you still have to check your instrumentation and make sure the data is correct.
Building trust takes time, and the next concrete test is already underway, running 2 identical aeration lanes in parallel, one controlled by AI, one by the current system and the operators.
And then we compare which one does the best and why, and we can learn from that.
If the AI system runs reliably, it could support the operators of big plants like the one in Tilburg, or improve autonomously running small-scale plants. And with new problems arising, AI could make a significant difference in the future.
In the future, we are looking into the big problem of forever chemicals like PFAS, microplastics, all these things that we need to do something about that, and that needs a different control strategy.
Clean water is fundamental to life. As wastewater treatment challenges grow, innovations are needed. Artificial intelligence is one promising option.